tal? Muy buen día. Sean todos bienvenidos al tercer día de la FEVIE. Agradecemos mucho que nos sigan acompañando. Han sido hasta ahora 2 jornadas muy exitosas con información de alto valor. Y bueno, hoy es nuestro tercer día y nos es un gusto dar inicio con la primera sesión. En esta ocasión nos va a acompañar nuestro buen amigo Mauro Zocchi. Mauro es el gerente regional de ventas de la compañía Frewitt. Frewitt, brevemente, los presento, es una compañía con más de 70 años de expertise en el campo de la molienda, de la reducción de partícula para el sector farmacéutico, el sector industrial. Y el día de hoy, como saben, el tema que Mauro nos va a compartir es uno muy interesante, muy diferente a lo que normalmente se maneja en este ámbito, que tiene que ver con la reducción de tamaño de partícula a nivel micronización bajo condiciones de vacío, digamos un proceso patentado por Frewitt a través de una solución muy particular que vamos a estar revisando. Y bueno, sin más, les recuerdo todas sus preguntas. Por favor, con plena confianza pueden levantar la manita a través de Zoom para abrir el micrófono o pueden escribirlas en el chat y las vamos almacenando para que al final de la sesión les podamos ir dando respuesta. También en un instante va a aparecer una breve encuesta de inicio para que nos apoyen con sus respuestas, sus comentarios, y al final de la sesión nuevamente va a aparecer y esperamos que haya nuevamente su participación. ¿Vale? Unos segunditos. Ok. Bueno, pues sin más, nuevamente agradecerles. Mauro,
Yep.
You are good to go.
Okay. Thank you. I'm ready. Can I go?
Yes, you can start sharing your nice presentation, please.
Can you see my presentation?
Not yet.
No? Right now?
Now
Okay.
we can see it. Thank you.
Thank you all. Thank you to all participants. Thank you for your time, for the interest in this webinar, and welcome to everyone. I would like first of all to present, to do a brief introduction into Frewitt and myself, then to speak a little bit about milling and micronization, then to go into some more details regarding the milling processes used for micronization, mainly pin mills and jet mills, and then give some attention to the main challenges that these processes are giving to the end users. And then going into technical features of the new development of a pin mill that I will be presented to you today. So Frewitt, my company, is a Swiss-based company. It's close to be 80 years old in a couple of years, and we have been developing several grinding and milling machines in these many years, and establishing as a leader in this field and anticipating needs of the market. So the company has been founded by an engineer called Frédéric Wittwer. It's French and German names, Frédéric Wittwer, which gives the name of the company. We are located in Switzerland in the central part in a bilingual zone where French and German is spoken. We are, maybe you are more familiar with Geneva and Zurich, talking about Switzerland. We are right, we have Zurich in the east and Geneva in the west, and Basel in the north. We are in the middle. I'm coming from the south, from the Italian part of Switzerland, and we are quite a multicultural little company. We have core values, Frewitt Total Care, mainly protecting the staff of our customers, protecting the environment of everyone, protecting your products, your APIs, and protecting your investment. These are the main core values of that we keep in mind while developing our machines for the market. And I would just want to go through a quick summary of what we have been doing. Like in 46, that was the foundation of the company, starting with oscillating mills. The engineer Vidver was considered was one of the main pioneers with this milling process, oscillating mills, to which then we added already 50 years ago the hammer mills, then developing the cylindrical sieve mills, going to the conical mills in the 90s. End of the 90s, we came out with some pressure shock resistant hammer mills, so 10 bar resistance unit. We further developed crushers, then laboratory mills, other crushers, some other laboratory mills, to come to in 2009 with a very nice development of 2 milling processes combined together, crushing and milling, to this mainly to give a solution to a existing problem of having products solidifying in big blocks, like metformin is a good example. So we developed this machine in order enabling to throw in the big blocks and go in one go to micronized fluid flowing powder. Cylindrical sieve mills of new design, new generation of oscillating mills. And then 10 years ago, we came out with a flex mill production and flex mill lab, are 2 platforms on which we can interchange several milling processes and up to 6 with the lab machine. So we added as well the pin mill for micronization, the nano milling. It's a wet and liquid form. A crusher that can be interchanged. We can go from an oscillating to a crusher, only changing the tooling. Cryogenic feeder, other crushers to come to the 2020 and 2000. Just recently, this new machine, the PMV 320, the larger pin mill that we are going to introduce to you today. A few words on just to fine tune. We call mills or fine milling all what is goes down to a D90 of 100, less than 100 microns, let's say, for which typically we use hammer mills for dry powders. By D90, we mean that 90% of the milled powder is below this target of, in this case, 100 microns. Pin mills can go much lower than 100 microns, as well as gem mills. They can reach D90s between 5 and 30 microns, that we call really the core of micronization. And this is, let's say, there are several interpretations of micronization, so we cannot be so precise, but every company looks at micronization in a different way. But in average, when we are going from a D90 of 5 microns to a D90 of 30 microns, it is generally called micronization. Then we can go lower down to nano size, but this is utilizing typically bead mills, which is a wet liquid process. Today, we'd like to concentrate on micronization. Yes, 1 second. Okay. This is a simple photo giving you a little bit the idea of how a pin mill looks like. There is the chamber with a door. The door has typically a stator with the pins, while inside the milling chamber, there is a drive, and is the dynamic, the rotor with the pins. And the product typically enters here, gets micronized here, and then exit at the bottom of the mill. There are different designs on the market. I just chosen one to give you more or less an idea of how the micronization takes place. It's the concept is an impact mill. It's not so different than hammer mill, but it looks with the pins, which you can see in this case there is 3 lines of pins, and here are 2 lines which are put in between, and there is a small gap in between, and there is a high speed which is typically higher than hammer mills. And conventional unit, normal unit, usually it's composed by a feeding unit, the pin mill itself, a cyclone filter, final filtration unit, pre-filter, semi-absolute, and absolute filter with pressure controls in order to control the pressure within the system. A nitrogen recirculation system is widely used as well. Sorry, I went back to the, and then of course a control unit and automation. This it's an overview of how it looks like with the dosing unit, going down to the pin mill. After the product is micronized, is carried in to a cyclone filter in order to separate the solid, the powder here going down, and the gas. And here we have some filtration unit. And then hereafter, we are going typically either in the final filtration system, or in a with a fan, we force the air through a heat exchanger in order to go back then into the system, and they still recycle the nitrogen to inertize the whole thing. Here we have an oxygen control. These are the spiral. I mean, I hope the explanation it's sufficient on how the pin mill works. If it's not, if I'm not clear enough, please ask if you have any question about that. I proceed with the. Sorry, I can take this away. I proceed this with the jet mills. In this case, we have spiral jet mills that are used. Spiral jet mills, this is again the mill itself, but and this is opposite jet mill, slightly different. I just wanted to show you that as well as the pin mill, it works with a dosing unit. Then it goes into the mill. This is a spiral jet mill, but at this place we can have an opposite jet mill. There is again a cyclone filter here, discharging the product down in the final container. There are controls. We don't see here the final filtration unit neither. And we should also consider that for spiral jet mills or the opposite jet mills, we also need an external compressor when we are using air, but more often an external tank of liquid nitrogen, because this process work. It's not a real mechanical process, but it works with the compressed gas. It's compressed gas which can reach 10 up to 12 bar, and which has typically an injection in just before the mill, the process gas coming here, and inside the milling chamber here, which is then distributed. This is a view from the top, through nozzles that accelerate the particles. So here the product fell down from a dosing unit. Typically, just to show the picture, this is the dosing unit. The hopper is a double screw dosing unit, and here is where the product falls down. And it enters this little hopper. Here we have an injector, which you can see better here. And here we have a Venturi system, which you can see here. So the compressed gas helps shooting the powder into the milling chamber tangentially from the top. And then once the powder is in, there is a second entry of compressed gas, which then is distributed in the milling chamber through nozzles. And here we have a decompression of gas through these nozzles. Typically the Laval nozzles are used, and the compression of the gas then accelerate the particles in a spiral movement. That's why this mills is called spiral jet mills. The particles entering here are accelerated to supersonic speed by the nozzles, and they collide against each other. This is a particle-to-particle process. They're accelerated very fast, and by centrifugal force, the larger particle remain at the periphery of the milling chamber, while the smaller one migrates to the center. Into the center, we have the fine product, which escapes with the process gas together. And typically, they are classified by this is the static classifiers, like a pipe entering in the mill. And the particle size distribution is controlled by using the feed rate and the energy and the bar as process parameters. This is a different concept, is always a jet mill, but here we have the entry of the powder coming from a feeding unit. And in this chamber, they fall to the bottom, where we have 3 jets converging to the center. And here is where the micronization takes place. Then the powder goes up, follows the stream of air, which is exiting the mill. And here on top, we have a classifier wheel. That's a mechanical component of this mill, which we don't have in the spiral jet mill. And depending on the speed of that we use for the wheel, for this classifier, the powder either goes through when it's fine enough or comes back to be further micronized when it's not fine enough. Again, as for the pin mills, we have a double screw feeding unit, typically the jet mill itself, which can be spiral opposite, cycle filter, final filtration unit, the controls unit and automation, and for sure an external compressor and an external tank of liquid nitrogen, right? So these are the 2 or 3 main processes that we are utilizing for micronization. And now we are coming out with a new pin mill, and which the one presenting today. And you might ask yourself, why a new pin mill? Because I mean, there are already pin mills on the market, right? The idea was to go and take a look at the main challenges that are with which the end user is confronted, and developing a pin mill that solves these challenges. So that solves these problems that are daily presented to the end user, and help them in having a much better mill. So it's not a new pin mill, but we wanted to do something very special. So these are the main challenges that to which the end user is confronted. Of course, he needs to get to a certain particle size distribution. He needs to avoid the heating of the product. I mean, heating of the product, it's something which is a constant, let's say, challenge using pin mills and spiral gel mills. Throughput as well, it needs to have enough productivity. Explosion risk and costly countermeasures. I mean, as finer as you go with micronization, with milling, as more the powder are explosive, the explosion danger is higher. So this is quite a big issue into micronization. Product retention. It's another problem that have and difficult cleaning as well. This is mainly also due to the large contact surfaces and large filtering units that are used. The installation footprint as well. I mean, you see that the mill is only a tiny part of the whole thing, but then you have a dosing unit, which is not huge for sure, but especially this part, the gas management part, the cyclone filter, where you need to separate the solid from the gas. This is quite important. So this large installation for gas management, and another quite high issue is the operation cost, because especially with nitrogen, in order to avoid explosion, nitrogen is also used to protect the product, not only for explosion, but these are a huge amount of nitrogen which are used, which are quite costly. Another challenge is the noise, because the jets are very noisy, and pin mills as well, running very fast. They are very noisy, up to 120 decibel. So this is what the end user always been confronted with, and we wanted to develop a solution without this problem, without this compromises. I would like to show you a video now. All right, that shows you a little bit, anticipates a little bit what we have done with this new pin mill. I'm very sorry. So coming back after this video, no more compromises between safety and performance. The development that we have brought to this mill is intended in order to give a safer, much safer mill to be used. and a lot of advantages that we go and take a look right now. PMV 320 is stands for pin mill and vacuum, because this machine works under vacuum, and 320 is the size of the let's say the nominal diameter of the milling chamber. Okay, here we see an overview of the entire installation. We have on top a charging station. We have a dosing station, and we have a milling chamber. Thereafter, we have a discharge station. The process under controlled vacuum is patented. We received the patent for Europe and United States, and we're waiting for more patents. Not only the under vacuum is for this pin mill has been received, but also the patent for other mills in our range. Milling under vacuum in general. We can see here that the whole installation is under vacuum. We have in the vacuum the charging, the dosing, the milling chamber, and the discharge station, which leads to one of the main advantages in this case is the zero risk of explosion. So for explosive products, we do not need any longer to deal with inertization of nitrogen. We do not need to deal any longer with 10 bar resistance, explosion-proof machines, which are very, very solid and heavy, and which are not really what we are looking for, especially in pharmaceutical application, when we need lighter units, also easy to assemble, disassemble, and clean. With working with under vacuum, we also have I would not say the noise level of 69 decibel. It's almost not noise. It's a silent level, right? 69 decibel. It's much less than now that I'm speaking. Speaking now, I'm much above. I'm at least on the 70, on the 80 decibel. So the machine is really so silent that just to make an example, when we were presented for the first time, this machine was a group of persons in the milling chamber, and after 10 minutes we were looking at each other and said, when we start milling, and they told us no, the machine was already running for the past 10 minutes. It's a very silent system. And we also have a low level of delta temperature. Low level of delta temperature for the fact that being under vacuum, there is also practically no air inside, no oxygen inside, and no risk of explosion, but also no friction and no, or a very limited, let's say, temperature increase, right? And at the same time, we are at the high containment level, which is less than 1 microgram per cubic meter. It's we are in full band OEB 5 because everything is sucked. I mean, there is no air inside. We are under vacuum. I mean, there is no chance at all for any part per million of particle to go outside of the machine. It's like being in an isolator. In fact, the first step before starting the production is a tightness test of the installation. It's an integrity test. Only after having passed this first step, we can start utilizing the machine. The machine works under pressure, which means it works at around 100 millibar. We could say that even, let's say, imagine we have an explosion, even if the explosion is not possible, would we have an explosion in any case for some exotic reason? I mean, being in 100 millibar and having an explosion which typically increase by tenfold the pressure, we go from 100 millibar to 1 bar, which is atmospheric pressure. So there is nothing that can endanger the product and nothing that can endanger the machine. So here we have the sections which are always under controlled vacuum, this is always under a controlled vacuum with no exception. This is the buffer, the dosing unit, and the milling chamber. Product buffer, dosing device, and milling chamber. And then we have the section that changes from vacuum to atmospheric pressure. The charging station is one of them, which means that we have the filling of this container with the vacuum conveyor bringing up the powder. And once that the powder is ready to be discharged, we go into vacuum mode with utilizing some special valves. Sorry, the same for the discharge station. I mean, when we have enough product to be discharged, then we change from under vacuum to atmospheric pressure, so that the product can easily fall by gravity into the receiving container. We have a vertical footprint. We have a width of 3.2 meters, a depth of 2.8, and a height of 5.4 meters. Here we can see with some more details. The control of this installation comes with an industrial PC, which we have a touch screen controlling the machine. The control cabinet can be placed under the machine on the catwalk or in the technical room. We have a set of 3 vacuum pumps which are delivered with the installation, and they are placed in their own skid. It's a skid of about 1 meter depth by 1.4 meter width and 2 meters high, which is to be installed in a separate technical room. And then from the technical room to installation, we need to have some rigid piping. We have an integrated conveying system. We can suck with the lungs the product freely from a drum, for like this. Or we can also use and aspirate the product from a bag discharging station, or a bag discharging station with some mills beneath, do some pre-crushing, like with safety cylindrical sieve mill, with a conical mill, with a hammer mill. We can also convey the product from an IBC discharge station We can convey it from a big bag discharge station. Or we can work on different floor level, having an IDC, let's say, on top, and just instead of the conveyor, we use a gravital feeding. If there are containment needs, we can work with, again, the discharge station from an IDC with using beta valves. We can work directly connecting to an isolator. Isolated discharge station. This back to the integrated conveying system. We have a first vacuum chamber. Here we see again in blue in atmospheric pressure. Here we have an integrated filter. Product is ready to be discharged, and this first vacuum chamber changes to under vacuum mode, and we can discharge the product. Dosing unit, milling chamber. And then we can start the next charging, going back to atmospheric pressure. Here we have a buffer with the feeding unit and the dosing device of feeding unit, yeah? And here we have the milling chamber with the pin mill. The rotor can reach up tip speed of 200 meters per second, depending on the application we are confronted. The average use of the motor of the rotor is 10 kilowatt, but there is power available up to 43 kilowatt, depending on the torque that we need. Stator and removable rotor mounted on a fully closed bearing head, protected by air or nitrogen supply of approximately 100 normal liters per minute. This is more or less the only gas that we need for our installation, which is really limited to a very small amount, so very, very extremely small consumption of gas. The complete milling head, bearing and stator cooled down by the integrated cooling jacket circuit, ensuring a stable temperature in the milling chamber. On top of the fact that we don't have air, we are under vacuum, so there is less friction, less heat generation. All around the milling chamber, we have a cooling jacket circuit, which further allows to keep the product temperature increase as limited as possible. We also deliver a chiller in order to stabilize the temperature of the system, of the milling chamber. And again, we have integrated in line the filtration. And with this in mind, you have noticed that we don't have any cyclone filter on the side, because the filtration of this unit is integrated into the machine. Also because there is no large volumes of process gas here. It's only a little bit of gas for protecting the bearing. So if you recall, the cyclone filter part, it's a quite, how do you say, important volume of the whole installation, which kind of doubles the footprint. And in our case, we don't have this cyclone on the side, let's say. So without using any nitrogen, we are in a standard zone 20 inside, so no risk of explosion or a dramatical increase to the limit risk of explosion. And also in the discharge station, we have an integrated filter. So during the discharge function, the outlet is under ambient atmospheric pressure. As outlet options, we can have a simple drum with its liner. We can have IBCs. We can have bag holding devices, pneumatical or mechanical. Big bag filler station. And we can also use a sampling device, which we have developed internally. We can use the continuous liner system. That's another own Frewitt device, the Profi liner. It's one of our modules, together with the sampling device and with the bag holding devices. This can guarantee an OEB level of 4 up to 5, depending on how the operator is working. We could also include a dosing station, and with this discharge and ambient temperature, ambient pressure. I mean, we can be quite precise in the weighing of the final packing. We can go to with another, in this case, with another pneumatic transfer into the discharge with alpha beta, if we are talking about containment in this case, or go to some isolators or contain pack off in this system, in this case. We can also, as an option, offer, in any case, the complete inertization of the mill with nitrogen and with oxygen control. This is not necessary really, but as every customer has his own internal regulation, in some cases we are asked for this as well. Another option is the VIP washing in place option with nozzle throughout the machine, and we have a vertical top-down system which is quite easily washed. So coming to an end of the presentation, we can say that we had in mind to develop a pin mill, but not a conventional pin mill as many which are out there, but something special, something that goes and gives you solution to existing problems of similar mills. So regarding the particle size distribution, we can offer a superior fineness, also due to the higher tip speed that this machine can reach, up to 250 meters per second. It's a particle size distribution that can compete with a spiral jet mill or opposite jet mill. We can achieve a stable temperature due to the due to the absence of air inside, and to also to the cooling of the milling chamber, as explained. Typically, we have 8 to 15 maximum 15 Celsius delta increase on temperature, so that the product remains protected. The machine can give very high throughput, up to 1 ton per hour. Closed bearings, safe for washing in place. This is the bearings and the only, let's say, small consumption of compressed gas that we have in the machine. We have a reduced footprint, an integrated dosing, miller, filters, and exhaust. Everything is concentrated in this vertical tower. So typically we take half of the space of a normal pin mill setup. So we consume, we have half of the footprint, half of the cubic meter are necessary for this kind of mill. The machine, in any case, can be fully customized to height restrictions, as well as to multi-floor level execution. Another feedback we had from the market is that it's very much appreciated the fact of not using textile fiber with the risk of having fibers in the product. We use the stainless steel filter material or conductive PTFE. So we have less consumables, and especially a great, an enormous difference in the consumption of process gas and nitrogen, especially, which is very, very expensive in this case. Reduced investment cost due to the integrated exhaust system, so we don't have the cyclone filter as a investment cost already is very interesting. Less filtering surface, it means less product retention and easier, faster cleaning and cleaning validation, which is another dramatic advantage here. ATEX without using nitrogen for inertization. The negative pressure of the mill ensures the high containment, so we don't need an isolator, in other words. Tightness test at every start. The machine is OEB 5 compatible. The lack of noise, very silent machine, so no problem for your operators. It is scalable to the lab scale pin mills we have and the pilot pin mills that we have. Patented, we said already, and it's a much safer solution than current pin mills as well. And at the end, we have it can substitute the air mill, the jet mills as well. So again, we have just to add some advantages. Yes, the washing in place, cleaning in place from top down, the 50% less footprint, minimum filtering surface, easy cleaning and maintenance, minimum nitrogen consumption. And here we see schematically more or less the size of this ore mill, and this size which goes from 0 to 3.5 meters more or less, and 5 meters in the height, and the size of the conventional pin mill, which goes up to 7 meters and up to more than 5 meters. Oh, what is that? Okay. Just as a final note, just on more on the commercial side than on the technical side, we have a comparison between the PMV, the ore mill, the 320, and the conventional pin mill operated with nitrogen, or a conventional pin mill which is X-proof, up to 10 bar resistant. Here we see that we have at least a 30% increase of cost. And then we have made also on a comparison with a spirogen mill, 400 millimeters. 500 millimeter would be more suited to the size of the pin mill on a 2 years operation, comparing, of course, the capital investment and the cost of operations, which can go up to double the cost of our pin mill. This is also mainly due to the incredible high amount of compressed gas that is used, right? The consumption in our PMV 320 is limited to 9 normal cubic meter per hour, and comparing to a similar mill out there in the market, which has 417 normal cubic meter per hour. So you see that there is a huge gap of consumption of processed gas, and when it is and when we are talking about nitrogen, which is mainly used against explosion for these fine particles, we have a cost of 46 Swiss francs per normal cubic meter. So it goes up to with 1,000 hours of milling. 1,000 hours of milling, it can go up to almost 200,000 Swiss francs. And the cost saving, let's say from 4,000 to 191, we have a cost saving of 187,000 Swiss francs. Just sorry for the small commercial invasion, but just to give you an idea of what is the saving potential and what is the quick return on investment in using this kind of mill. Okay, so far so good. I mean, thank you very much for your patience. I hope I have not been too long, and hope to have given you enough thoughts. Think about it, and I would be pleased also if you would have some questions.
Thank you very much, Mauro, for the presentation.
Thank you,
It
Ruben.
was indeed very informative.
Thank you, everyone.
Let me change to Spanish and coordinate the questions from our attendants. Bueno, a todos, estimados amigos, muchas gracias por su participación hasta este momento. Nos gustaría abrir el foro de preguntas. Por favor, si nos quieren compartir algo, ya sea a través del chat o levantando la manita aquí en Zoom y abriendo el micrófono, creo que es el momento de aprovechar. Mauro nos presentó información que tiene bastante valor tecnológico, como bien lo dijo, que nos da a pensar en muchas posibilidades, no solo por la máquina misma, no solo por que tengamos una necesidad de un proceso de micronización, sino que incluso como una idea de negocio para todos ustedes dentro de sus propias plantas. Ahora saben que hay alguna tecnología por ahí bien desarrollada por la persona o por la compañía correcta y que puede traer muchos beneficios. Tenemos una primera pregunta en el chat que nos dicen: ¿las condiciones de vacío se pueden usar en otros molinos de Frewitt? Mauro, we have a question. The first one is, can we take the vacuum conditions from this process into different milling technologies from Frewitt? For example, if we want vacuum conditions in a conical mill or in a hammer mill, is that possible?
Well, I believe so. I believe so. I cannot answer with a certitude 100%, but because actually I've not already experienced such a project. I don't know if any of my colleagues went into that. From my end, not yet. But having patented this pin mill, but not only this pin mill, but the other mills as well, for under vacuum, yes, I would say that the answer is yes.
Okay. La respuesta entonces es preliminarmente que sí. Naturalmente es una solución muy nueva, hay que analizarlo caso por caso, pero el potencial existe para poder llevarlo a otro tipo de tecnologías. Another question, Mauro, is how easy is it to disassemble and clean the machine?
How easy is disassemble the cleaning machine? So the machine, it's vertical. It can have washing in place nozzles, which are distributed from the charging station through the dosing station to the rest. So typically, this is an option that we would suggest. And then, yes, there are some parts which are heavy, but these parts can be, how do you say, lifted with a sort of include a crane, which is included in the machine. Yeah. And all the rest, it's tree clamp connected and quite easily disassembled and can be taken away to the washing room, let's say, for final cleaning.
Super. Ok. ¿Alguna otra pregunta? ¿Alguien más quiere levantar la manita y participar? Todas sus preguntas enriquecen mucho la sesión. Todas las preguntas son buenas, principalmente aquellas que no se puedan responder, porque esas son las que nos dan material para pensar y para mejorar. Okay, we got another question, Mauro, which is, which are the measures to take care of the rotor in this machine?
The what you said? Sorry,
How should we take care of the rotor of this machine, the handling, in order to avoid any damage to the rotor?
How to take care of the, I mean,
Let's
yes.
say, how do we avoid to damage the rotor when we take it out for cleaning, for example?
Well, in this case, I would say yes, as you do with any other part of a rotor of a machine or a milling head or a component. I mean, this in this case being on a structure which is not on ground floor. I think that it would be interesting to have some kind of forklift, right, in order to access to the upper level, and having some forklift or some pallet or container. I mean, and then place these parts in the container and then lift them down to the floor. This I would consider this instead of going up and down the stairs with and carrying everything by hand, right? Also because some of these parts can be quite heavy, but always with this crane assistance that helps a lot.
Okay, thank you very much. Bueno, ¿alguna otra pregunta? Si no hay más, pues agradecemos mucho la participación. También hacemos aprovecho el espacio para como se dice, una breve invitación. En la semana del 6 de marzo, Mauro va a estar por acá en México. Y junto con su servidor, nos gustaría mucho para los que
tienes una pregunta en el chat.
Ah, correcto. De extra, sí. ¿Cuál sería el tamaño de partícula más conveniente para alimentar el micronizador? Mauro, we got another question which says, which might be the right particle size at the feeding of the machine? The initial particle size when we feed the powder into the machine, to the mill.
This can vary, but I mean, as usual, as fine as we are, as easier it is to reach a very fine particle size distribution, right? I would say that anything coming out of a conical mill, oscillating mill, it's good for the then going down to micronization. you could even use a hammer mill to be even finer. But even, I mean, out of a crusher, I would not go out of a crusher with 1-2 centimeters, let's say, because this, well, this is probably almost too large, yes. But anyway, I mean, keep in mind that if I start, if I want to reach 10 micron, and if I start from 100 micron, it will be much easier, and I can have a much higher productivity than not starting from 500 microns. All right, or starting from 1 millimeter, then I would drastically abate the productivity of the machine. Or maybe I can reach the particle size distribution in 2 steps instead of 1, which is crazy to think about. No, it depends very much on each product, of course. Every product has different behavior, but the rule is always before you go into micronization to have already a fine powder.
Okay.
So I perhaps without going to D100 less than the D90 less than 100 of a hammer mill, you could also start with a conical mill or oscillating mill between 2, 3, 500 microns. Why not? But finally, well, this is to answer really this question, we should perform some trials. This is always the best thing, because there are so many products out there behaving so much, in so many different ways. And by the way, let me perhaps add something. For this spatial mill, we are also open to consider on a case by case, and of course, after having do a preliminary qualification of the product by a specialist. Let's say we need to know what kind of product it is. You need to have the safety data sheets, the HS code, and everything. If we can qualify and have a clear picture of the product, we might also be in a position to offer free of charge trials, which at our site. Of course, the customer then needs to send the product up to us and then pick it up and get it back home. But from arrival of the product in Switzerland to the trials, to the readiness to be picked up to come back, we could do this free of charge, which, believe me, it's saving a lot of money. Yes, and okay. But would we have an interesting customer, an interested customer for our mill, and would we correctly qualify the application and the product, given the feasibility, of course, right? Depends also on the activity of the product. But then, yes, then in this case, we would be happy also to offer free of charge a trial.
Okay. Thank you.
That would, and in these cases, we could also work, maybe a customer could come and say, I have here a product which comes out of a cone mill. I have here a product which comes out of a hammer mill with quite different particle size distribution. And I have here my final target, so many microns to achieve at the end, or a micronized product. And so we could do trials with one product and with the other product. I mean, the same product milled in different particle size, and see the impact that it has.
Okay. Okay. Bueno.
I hope my answer was exhaustive, but if not,
it was clear, Mauro. It was clear.
Thank you. Thank you.
Bueno. Ok. Parece que ya no tenemos más. Entonces, agradecemos nuevamente. Mauro, thank you very much for your time, for the presentation.
Oh, I thank you all for your time and for the interest in my presentation. I'm very pleased about this. And as Ruben just said, I will be in Mexico in 2 weeks time, and if anyone would be interested in exploring more about this product, I would be happy to be available.
Of course. Bueno, pues amigos, los invitamos también a la siguiente plática que tenemos ahora con nuestros colegas de IWT, referente a los rack modulares y temas de validación de limpieza en sistemas automáticos, a las 11:30. Entonces, esperamos contar con su participación y muchas gracias.
Thank you.